Power and energy. Power is defined as work done over an elapsed time, which simply means the amount of energy used or transferred over time, as represented by the formula power equals work over time, where power is measured in units joules per second or watts. This formula can be rearranged to form work or energy equals power multiplied by time, where energy is measured in joules. When a voltage source such as a battery is applied to an electrical circuit, this results in a flow of electrons or electrical charge known as current. The voltage does work to move these electrons in the circuit, and hence, this work done over time is the electric power of the circuit. The greater the voltage in the circuit, the greater the current flow. In other words, more work is done over time, so the power increases. From this relationship, it can be concluded that power is directly proportional to voltage. To demonstrate this relationship, the power formula can be manipulated as follows. The formula for energy can be expressed as work equals charge times voltage. Subbing this into the power formula, this gives power equals charge times voltage all over time. Furthermore, current can be expressed as current equals charge divided by time. Therefore, this gives the formula for power in a circuit to be power equals voltage times current. The power formula P equals VI can now be manipulated using Ohm's law V equals IR. When rearranged for current, this gives I equals V on R, and this can be substituted into the power formula for I, which gives P equals V squared on R. Using this new power formula, IR can be directly substituted for V, which gives P equals I squared times R. The following example requires the power supplied by the battery to be calculated. The first thing you want to do is calculate the total resistance by using a combination of the total resistance formulas for series and parallel circuits. From this, you'll find the total resistance equals 166.67 ohms. Using the Ohm's law manipulated power formula, P equals V squared on R, the voltage and resistance can be substituted in. This gives a power of 0.864 watts. The second example requires the electrical energy consumed by a light to be calculated. The time firstly needs to be converted to seconds, and this is done by multiplying 25 minutes by 60 seconds. Then substituting all the values into work equals power multiplied by time, this gives an energy of 90 kilojoules.